Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 1 exam for AS Physics for February-March 2024. So let's get started. Question 1 says which row shows a physical quantity and its base unit in the SI system. So only ampere is the base unit, newtons is an SI unit, grams and degrees Celsius are not SI units, but only ampere is the base unit for the current, so the answer is A. Question 2 says a car of mass 850 kilograms is traveling in a horizontal straight line. The diagram shows the two horizontal forces acting on the car in opposite directions. One force has a magnitude 1200 and the other has a magnitude 1600. What is the magnitude of the acceleration of the car? So acceleration is equal to resultant force divided by mass. So we can calculate the resultant force by subtracting 1600 minus 1200 and then we divide by the mass 850. That gives an answer of 0.470588, which we can approximate to 0.47. So the answer is A. Question 3 says an object of mass m is suspended by a spring from a fixed point. The spring has a spring constant k. The object is set into vertical oscillation of period t, which equation for t is homogeneous with respect to base units. That means the base units on the left hand side is equal to the right hand side of an equation. So on the left hand side in all the choices we have time, which has base unit seconds, and we need to check the right hand side for each equation. 2 pi is a constant without units, so it has no units in all the equations. Now trying A. For k, the spring constant is equal to the force divided by the extension, and force is equal to mass in kilograms multiplied by acceleration in meters per second squared, and then we divide by the distance in meters, so the final unit of k is kilograms per second squared. So trying in A, that's kilograms per second squared divided by kilograms, and we are left by second to the power of -2, not second to the power of 1. For B, we have kilograms divided by kilograms per second squared. Again, kilograms cancel, and we are left with second to the power of 2, not 1, so it's not B either. Next, we have kilograms per second squared over kilograms, and then we have a power of half for the root. So kilograms cancel, and we are left with second to the power of -2 to the power of half. That's -1, not 1. So again, it's not C, not B, not A. It must be D. Question 4 says an object of fixed mass is initially at rest at point P. The object then moves away from point P with uniform acceleration. Which statement describes the resultant force acting on the object when it is moving? So we have a uniform acceleration. That means that there is a resultant force. It's not zero. And it must be constant in magnitude. So the force increases, no. Constant but not zero, yes. Proportional to displacement, no. It is zero, no. So the answer is B. Question 5 says a projectile is launched at an angle of 25 degrees to the horizontal with a horizontal component of velocity 30 meters per second. What is the vertical component of the velocity of the projectile when it is launched? So we have the launch angle is 25 degrees to the horizontal, and we have the horizontal component 13, and we need to know the vertical component. We can use the tan. We can say that tan 25 is equal to the unknown velocity over 13, opposite over adjacent. So the unknown velocity is equal to 13 times tan 25. That gives an answer of 6.062, which is approximately 6.1. So the answer is B. Question 6 says a ball is released from rest at point X at time 0 at 1 second. It bounces inelastically from a horizontal surface and rebounds, reaching the top of its first bounce at 1.5 seconds. What is the total displacement of the ball from its original position? So the displacement in a velocity time graph is equal to the area under the graph, but since we have positive and negative velocities, we calculate the areas and then we subtract the areas in opposite sides of the x-axis. So we have the first area is half times the base 1 times the height 10 for a triangle. And we subtract half times the base 0.5 from 1 to 1.5 times the height 5. That gives an answer of 3.75 meters, so it is B. Question 7 says what is the definition of acceleration? It is the rate of change of velocity, so change in velocity per unit time, yes. Rate of change of speed, no, it's a vector quantity, not a scalar quantity. Rate of change of velocity per unit time. Rate of change of velocity per unit time, that's like dividing by time twice. So it's either rate of or per unit time, so this is wrong. resultant force per unit mass? Yes, but it is not the definition, it's just a way of calculation. So the definition is A. Question 8 says two balls P and Q of equal mass move along a straight line directly towards each other. As shown, ball P has velocity 1.3 meters per second to the right, ball Q has velocity 0.5 meters per second to the left. P and Q collide with one another, the collision is perfectly elastic, and the total momentum is conserved. Which diagram correctly shows the motion of P and Q after the collision? So since the masses are missing, we have to use the concept of relative velocity of approach and relative velocity of separation. So relative velocity of approach is u1 minus u2. If we consider P to be 1 and Q to be 2, we have 1.30 minus negative 0.50 because it's in the opposite direction. So the total relative velocity of approach is 1.80, and the collision is perfectly elastic. That means that the relative velocity of separation should also be 1.80. So we have here the choices. We calculate V2 minus V1 to get the separation. So here we calculate 0.58 minus 0.22. That will not give an answer of 1.80. Here there is no separation because they have the same velocity. So the separation is 0, so it's not B. In C, we have 0.99 minus negative 0.19. That gives an answer of 1.18, not 1.80, so it's not C, it must be D. And we have actually the same magnitudes of velocities and opposite directions again, so this will give an answer of 1.80 as a relative velocity of separation. Question 9 says a basketball player hits a ball vertically downwards with a speed of 2.4 meters per second from a height of 0.90 meters. Air resistance is negligible. What is the speed of the ball as it hits the ground? So we can use the law of conservation of energy since we have speeds and heights. So we can use kinetic and potential energies. Gravitational potential energy initial plus kinetic energy initial is equal to gravitational potential energy final plus kinetic energy final plus wasted energy or losses. And here air resistance is negligible, so the losses are 0, and at the ground there is no height, so the final gravitational potential energy is 0. But we have initial kinetic and gravitational potential energies, so the gravitational potential energy is equal to m times 9.81 times the height 0.9, and the kinetic energy is equal to half times the mass m times the initial velocity 2.4 squared, and that is equal to half times the mass times the final velocity, which is unknown, squared. Since the mass is in all terms in the equation, we can cancel the mass or divide by the mass on both sides of the equation, and it was not given in the question because you do not need it. So we are left with 9.81 times 0.9 plus half times 2.4 squared, and then we divide that by half from the other side to get v squared. But to get v, we need to square root all that. This gives an answer for the velocity 4.8392 approximately, so it's approximately 4.8, so we choose B. Question 10 says a ball falls through a liquid at constant speed. It is acted upon by three forces: an upthrust, a drag force, and its weight. So falling, that means that the motion is downwards, so the drag force must be opposite to the motion, so it's upwards. And at constant speed, that means that the forces upwards balance the forces downwards. The upthrust is always acting upwards and the weight is always acting downwards. So the weight must be equal to the sum of the upthrust and the drag force. So we have the liquid has a uniform density. Which statement is correct? The drag force increases with increasing depth. No, because the speed is constant. Drag force increases as speed increases, so it does not increase when the speed is constant. The drag force is equal to the sum of the upthrust and weight. No, the weight is equal to the sum of the drag and upthrust. The upthrust is constant with increasing depth. Yes, because the upthrust is calculated as rho vg, and the density of the liquid, the volume submerged of the object, and the gravity field strength are all constants, so this would be constant, so the answer is C. Question 11 says some small solid cubes each have mass 1 kilogram and sides of length 5 centimeters. These small cubes are stacked together to form a large solid cube with sides of length 2 meters. What is the weight of the large cube? So we need to know how many cubes of the small ones are stacked in the large cube. So we divide the volume, not the dimensions. So we divide the total volume of the large cube, which is 200 centimeter cubed. So 200 cubed. And we divide that by the volume of one small cube, which is 5 cubed 4 centimeter cubed again. That gives a number of 64,000 cubes in the large cube. And we have the mass of each cube, 1 kilogram. So we multiply that by 1, and then we multiply it by 9.81 to get the weight. That gives an answer of 627,840. So that's not 0.39, not 39. It is 6363, but it is not giganewton. It's not in billions, it's in millions. It's just below a million. So the answer is C. Question 12 says, a borehole of depth 2000 meters contains both oil and water. As shown, the pressure due to the liquids at the bottom of the borehole is 17.5 megapascal. The density of the oil is 830 kilograms per meter cubed, and the density of the water is 1000 kilograms per meter cubed. What is the depth x of the oil? So we can say that the total pressure is equal to the pressure of the oil plus the pressure of the water. So 17.5 times 10 to the power of 6 for mega is equal to the density of the oil, which is 830 multiplied by 9.81 multiplied by the depth x, and we add the pressure of the water, which is 1000 times 9.81 times the depth 2000 minus x, because we have the height from here to here is equal to the depth of the water, and we can divide by 9.81 on both sides of the equation. So 17.5 times 10 to the power of 6 over 9.81, that is equal to 830x plus 1000 times 2000 minus x. So we can simplify this, 830x plus 2000 times 1000, that's 2 times 10 to the power of 6 minus 1000x, and then we subtract by this. So we have 17.5 times 10 to the power of 6 over 9.81 is equal to 830x minus 1000x. That's negative 170x. So we divide by negative 170. So we divide this bracket by negative 170. You get an x value for this depth of 1271, which is approximately 1270 meters. So the answer is D. Question 13 says, a rod is pivoted at one end. Initially, the angle theta of the rod to the horizontal is 0. The weight of the rod causes a moment m about the pivot. The rod is then rotated in the vertical plane so that the angle theta of the rod increases from 0 degrees to 180 degrees. Which graph shows the variation of m with theta? So if the rod was initially like this, horizontal, and the weight has a perpendicular distance d from the pivot, as the rod rotates, there is an angle theta here. So the weight is causing a new moment, and the perpendicular distance is not equal to the distance d, it is equal to d cosine theta. So we need a cosine graph, so we choose D. Question 14 says, a hinged trapdoor is held closed in horizontal position by a cable. 3 forces act on the trapdoor: the weight W of the door, the tension T in the cable, and the force H at the hinge, which is a reaction force. Which list gives the 3 forces in increasing order from minimum to maximum order of magnitude? So we have only the tension acting upwards, which means it must be the greatest force to support both H and W. So we check the answers, only T at the end at C, so we choose C. Question 15 says, what is the definition of a force? It is the rate of change of momentum, and we have that at C, so this is the answer. Question 16 says, a boat moves at constant velocity v through still water. A constant drag force F acts on the boat. What is the power used by the boat to move through the water? Power is equal to force times velocity, so we choose B. Question 17 says, a diagram shows 4 forces acting on a circular disk. Each force has a magnitude F. 2 of the forces act vertically and the other 2 forces act horizontally. All 4 forces act in the same plane as the disk. No other forces act on the disk. The disk has diameter d, so this distance is d, and the vertical distance is also d. So we have 2 couples. These 2 forces form a couple, and these 2 forces form another couple. And these all have clockwise moments, so there is a resultant moment or resultant torque on the disk. Which statement is correct? The disk in equilibrium? No, it is not in equilibrium. So A and C are rejected. Because the resultant force is F? No, actually all forces cancel each other. We have F upwards, F downwards, F right, F left. so the resultant is not 4F, it is 0. The resultant torque is 2FD, yes, because we calculate torque as a force of one of the forces, magnitude of one of the forces multiplied by the perpendicular distance, and we have two of them, two couples, so two torques, so we multiply that by 2, giving the answer 2FD, so we choose D. Question 18 says a ball is projected into the air from horizontal ground and follows the path shown in the diagram. At points Q, R, S, and T, the ball has kinetic energies EQ, ER, ES, and ET respectively. The heights above the ground of these 4 points are shown. Air resistance is negligible. Which difference in kinetic energies is the smallest? So the kinetic energy change depends on the gravitational potential energy change, which depends on the heights. So for Q and S, we have 1.5 and 1.6. For S and R, we have 1.6 and 1.8. For T and Q, we have 1.3 and 1.5. For T and R, we have 1.3 and 1.8. These all, if subtracted from each other, we have the smallest number will be in A. Question 19 says the battery of a small tablet computer is initially uncharged. It is connected to a constant 10-watt power supply for 2 hours to charge the battery. The efficiency of the charging process is 80%. What is the total energy stored in the battery? We can use energy is equal to power multiplied by time, but then we multiply by the efficiency. So we have 10 watt multiplied by 2 hours, and then we convert that to seconds. So times 60 times 60. And then we multiply by the efficiency 80 over 100 for 80%. That gives an answer of 57,600. So that's 5.8 times 10 to the power of 4. So we choose C. Question 20 says an initially stationary firework explodes and splits into 2 fragments that move horizontally in opposite directions. The total kinetic energy transferred to the fragments by the explosion is E. One fragment has a mass m and the other fragment has a mass 2m. What is the speed of the fragment of mass m immediately after the explosion? So, following the rules of conservation of momentum, if we have 2 objects exploding in opposite directions, they have equal and opposite momenta because they were stationary at first. So the total momentum before the explosion and total momentum after the explosion is equal to 0. So the magnitude of the momentum of the small mass m times velocity v is equal to the momentum of the other mass, which is 2m. So it must have velocity v over 2, so that the magnitudes of the momentum must be equal. And then substituting with energy, that's kinetic energy, so half mv squared for the small mass plus half 2m times v over 2 all squared for the larger mass. So E is equal to half mv squared plus, and these will cancel out, and we have 2 to the power of 2, that's 1 over 4, then mv squared. So E is equal to half plus 1 over 4, that's 3 over 4 mv squared. If we make v squared the subject of the formula, v squared will be equal 4e over 3m. So v will be equal to root 4e over 3m, so we choose D. Question 21 says a spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic potential energy EP. The spring constant is K. The spring obeys Hooke's law. Which relationship is correct for the spring? The elastic potential energy is proportional to what? So elastic potential energy is equal to half times the force times the extension. But if we need to make the force the only variable, we have to substitute extension with force over spring constant. So this will be equal to half F times F over K, so F squared over K. Or we have another equation that the elastic potential energy is equal to half Kx squared. So here both variables change, so we cannot use this. In this case, half times 1 over k is a constant, so EP is proportional to f squared, so it is not proportional to f, it should be squared. And according to the last equation, it is not proportional to x, it should be squared again. It is not proportional to k because k is constant and the energy can change, so it is not C, it must be D according to the last equation. It is proportional to x squared. Question 22 says a force extension graph is produced for a metal wire. What must describe the limit of proportionality of the wire? It is the point at which the wire breaks. No, it is the point beyond which Hooke's law is not obeyed. Yes, because Hooke's law states that the force and extension are directly proportional, and after that point it will no longer be proportional. The point beyond which the wire cannot return to its original length, the point beyond which the wire starts to deform plastically, these are basically the same thing. That's elastic limit, not limit of proportionality. So the answer is B. Question 23 says a spring has a spring constant of 6.0 newtons per centimeter. It is joined to another spring whose spring constant is 4.0 newton per centimeter. A load of 80 newtons is suspended from this composite spring. What is the extension of this composite spring? So we need to calculate the extensions of each spring and then we add them. So the first extension is equal to the force divided by the spring constant. So we have 80 divided by 6.0, and we have 80, the same force is transmitted, divided by 4.0, and then we add these two together. That will give a total extension of 33.3 recurring, so we choose D. Question 24 says the range of frequencies of sound waves emitted by blue whales is 10 Hz to 40 Hz. The speed of sound in seawater is approximately 1.5 kilometers per second, not meter per second. So this is 1,500 meters per second. What is the approximate range of the wavelength of the sound waves emitted by the blue whales? So we can use wavelength is equal to speed divided by frequency 2 times. For the first frequency, we have 1500 divided by 10, that's 150 meters. And we have 1500 divided by 40, that's 37.5 meters. So we choose D because we have 38 meters, which is approximate value for 37.5 and 150 meters. So this is the answer. Question 25 says a sound wave is detected by a microphone and displayed on the screen of a cathode ray oscilloscope. We have the wave makes periodic time of 4 centimeters on the x-axis of the screen, and the frequency of the wave 2.5 kilohertz, that's 2500 hertz. What is the time-based setting of the CRO? So we need 1 centimeter represents how much time? So first we calculate the periodic time of the wave, which is equal to 1 over the frequency, so 1 over 2500. That gives a value of 4 times 10 to the power of negative 4. So if this is for 4 centimeters on the screen, how much time is for 1 centimeter? That will be 1 times 10 to the power of negative 4 seconds. And we have the choices either second per centimeter or millisecond per centimeter. So if we need to convert this to milliseconds, that will be times 10 to the power of negative 3. So this will be 0.1 milliseconds. So we choose A. Question 26 says a source of sound waves with constant frequency moves towards a stationary observer. The observer compares the sound waves arriving at the observer's position with the waves emitted by the source of the sound. What is detected by the observer? A decrease in frequency? No, if an object is moving towards an observer, the observer will receive a higher frequency, so it's not a decrease, it is not no change. It's a decrease in wavelength, which means an increase in frequency, so we choose C. Question 27 says which type of waves cannot be polarized? That's longitudinal waves. The example for longitudinal waves is sound waves, so we choose B. Question 28 says a beam of light with power P has an area of cross-section A. The amplitude of light waves in the beam is X. The beam of light is then changed to one with the same frequency but with an increased amplitude of 4x and an area of cross-section reduced to A over 3. So we have first the relationship between intensity and power. Intensity is equal to power divided by area. Also that intensity is directly proportional to, also we have a relation says that intensity is proportional to amplitude squared. So if the amplitude is multiplied by 4, that means that the intensity is multiplied by 4 squared, so multiplied by 16. And here we do not use the equation for the intensity with area because it says that the initial beam was with a larger area and the new beam will have a smaller area, which means we decreased the power or decreased the amount of light. So this is area over 3, so the power will be decreased by 3. And intensity multiplied by 16, that means that the power is multiplied by 16. So we have a ratio of 16 divided by 3 for the new power. So 16 divided by 3, that's approximately 5.3, so we choose B. Question 29 says two loudspeakers are connected to the same signal generator. The signal generator produces a single frequency. The loudspeakers face each other so that a station wave is set up in the region between the loudspeakers. A microwave is connected to a cathode ray oscilloscope and positioned between the two loudspeakers. The microphone is moved along the line joining the two loudspeakers. The signal on the CRO shows 5 maximum amplitudes, that's 5 antinodes, as the microwave moves. The microphone moves a distance of 2 meters from the position of the first maximum to the position of the fifth maximum. So if we draw the waves like this, we have the standing wave like this, and we draw the closing of the loops. So we have nodes and antinodes. So we started at the first antinode. The second antinode is here, third is here, fourth is here, and fifth is here. So that's from the first to the fifth antinode. And this whole distance is 2 meters. So checking for the wavelength, from here to here that's one wavelength, and from here to here that's another wavelength. So 2 meters is equal to twice the wavelength. What is the wavelength of the sound wave? So if 2 meters is equal to twice the wavelength will be 1 meter. So we choose D. Question 30 says two wave sources emit coherent waves. Which condition must be correct for the coherent waves? Waves are emitted in phase, not necessarily. The waves are emitted and move in opposite directions, not a must. The waves are emitted with constant phase difference. Yes, that is the definition for coherent waves, or constant frequency or same frequency. So we choose C. Question 31 says a student sets up an experiment to investigate double slit interference. The student uses light of a single wavelength from a laser to illuminate a double slit so that a pattern of interference fringes is observed on the screen. The student finds that the fringes are very close together. What could the student decrease in order to increase the separation of the fringes on the screen? So the equation for a double slit experiment is lambda is equal to AX over D. In this diagram, lambda is the same. A is called R here, the slit separation, and X is a fringe separation, and D is called Q in the diagram. So if we need to investigate X, X will be equal to lambda times Q over R. So if we need to increase X, we need to either increase the wavelength, increase the value of Q, or decrease R. So we need to decrease something here. We look for R. So the separation R of the slits. So the answer is C. Question 32 says, what are the definitions of potential difference and electromotive force in terms of energy transfer W and charge Q? So basically they are the same thing. It is energy per unit charge. So work over charge. So we choose A. Question 33 says a diagram shows a network consisting of 3 resistors. What is the combined resistance of the network between terminal X and Y? From X to Y we have 2 objects in series, so the 2.2 kilo ohms and the combination of these 2 resistors are connected in series. But inside the connection we have a parallel connection, so we start from inside and go outwards. So we calculate the parallel connection first. 1.2 times 4.7 over 1.2 plus 4.7, product over sum for the parallel connection, and then we add the series resistor 2.2, and we have the answers are in kilo ohms and the resistors are also in kilo ohms, so we do not need to convert. This will give an answer of 3.15593, which we can approximate to 3.2 kilo ohms, so the answer is C. Question 34 says a resistor dissipates 25 watts of power when there is a potential difference of 4 volts across it. What is the resistance of the resistor? We can use the equation power is equal to V squared over R. So R is equal to V squared over P. So we have 4 squared divided by 25. That gives an answer of 0.64 ohms. So the answer is B. Question 35 says the diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. The resistance of the variable resistor is decreased. What happens to the potential difference V across the variable resistor and the current I in the variable resistor? So V is actually the potential difference across the terminals of the battery. If the resistance or the total resistance in the circuit decreased, the total current in the circuit will increase, and the voltage output from the battery is equal to EMF minus IR, which is the voltage drop inside the battery. If the current increased, the negative part of the equation will increase, so the voltage will decrease, so V will decrease. Now, if the current increased and the voltage across this part decreased, we have for the fixed resistor, the voltage and current are directly proportional. So if V decreases, the current here in this resistor will decrease, but the current outside increased, so this one must increase to support the increase in the current in the total circuit. So the current I actually increases in this situation because there is a parallel connection and a fixed resistor. So we choose B. Question 36 says a radioactive source produces a beam of alpha particles in a vacuum. The average current caused by the alpha particles in the beam is 1.5 times 10⁻⁹ amperes. The beam is incident on a metal target. What is the average number of alpha particles hitting the metal target in a time of 3 seconds? So we have current and time, so current is equal to charge divided by time, and the charge is equal to the number of charge carriers multiplied by the charge of one carrier, which is here an alpha particle. An alpha particle has a charge of 2e for 2 protons, and then we divide by time, and we need to calculate the number. So the number will be equal to current times time over 2e. So we divide 1.5 times 10⁻⁹ times the time 3 seconds over 2 times the charge of 1 electron, which is in the formula sheet 1.6 times 10⁻⁻19. That gives a value of 1.406 times 10⁻⁻10, so we choose C. Question 37 says that charge carriers in a metal wire are free electrons. Which statement about the charge of each free electron is correct? The magnitude of the charge increases. No, it should be constant, and it is not zero. The sign and magnitude of the charge do not depend on potential difference. Yes. The sign of the charge depends. No, the charge carriers which are free electrons have constant magnitude and constant sign. So the answer is C. Question 38 says which flavors of quark have charge positive 2/3e? That's the charm and the top quarks. Strange and bottom quarks have a charge of negative 1/3e. So this is correct. This is not correct. This is correct. This is not correct. So the common answer is A. Question 39 says an unstable nucleus of an element decays by emitting an alpha particle or a beta particle to become a nucleus of a different element. This nucleus is also unstable and emits an alpha particle or a beta particle. The process continues until an isotope of the original element is produced. That means we return to the same proton number. So an alpha emission decreases the nucleon number by 4 and decreases the proton number by 2. So we need to increase the proton number by 2 again. But each one beta negative emission doesn't change the upper number and increases the lower number, the proton number, by 1. So we need 2 beta particles to be emitted to return to the original value of the proton number. So we have 1 alpha and 2 beta emissions. So the minimum possible number of these particles emitted is 3. So we choose B. Question 40 says a nucleus of carbon 10, C10 and 6 decays by a beta emission to form a nucleus of boron 10, 10 and 5. For this decay process, what is the change of a nucleon and what is the change in the quark composition of the nucleon? So if we write the equation, carbon 10 and 6 will be converted to boron 10 and 5. So we need a beta which has a proton number positive 1 and 0 nucleon number. So this is a beta positive emission. So in beta positive emission, a proton changes into a neutron. And for a beta negative, that's a neutron to a proton. So C and D are rejected. And the change in the flavors, we have a proton consisting of an up and a down quark. And for a neutron, that's up and down and down. So one up quark changes into a down quark. So up becomes down. So we choose B. Now this was the end of the exam. I hope you enjoyed this video and found it useful to you. Keep practicing and I will see you in another video.